So here we are once again at our friendly neighborhood NCBI page, and our goal today is to investigate how to transform the cDNA sequence that we collect from NCBI into an amino acid sequence that we can use in the remainder of our project. So let's again return to this KRAS gene that we're all becoming more and more familiar with as the course continues. And we're going to scroll down. You can also use the links here. We're going to NCBI reference sequences RefSeq. And go all the way down the page, and we're going to find this information. Here we are. And what we want to get the cDNA, the complementary DNA to the mRNA, which is what will be translated into the protein, is to click on this NM followed by a series of numbers. And then we're going to use this link here on the far left entitled FASTA. And FASTA just means that this is formatted in a way that a lot of software working with genetic material is able to use. And here you can see that we've got the entire mRNA sequence for this very long gene ready to go. And what we're going to do is we're going to leave this here as a link so that we can come back for it when we're ready to translate this into an amino acid sequence. So our next step is to open a new tab in our browser and go to expasy.org, and we're going to be looking specifically for the proteomics features that this website has to offer. This has a vast array of tools for studying various types of genetic information, and unfortunately we just don't have time to look at most of them. So we're going to go straight down to protein sequences and identification, and we're going to go over here to the translate link in this tools column under protein sequences and identification. And here, this is where we're going to paste our mRNA or cDNA sequence. Now this is, you can tell this is not actually mRNA, correct, because it has thymines in it. So what is listed here is the cDNA. So we'll paste that in, get rid of some of these extra spaces, and we're going to translate the sequence. And immediately what you see here are a set of possible reading frames through which this might be read. So in the first reading frame, the beginning of that complementary DNA sequence would be translated as a serine, followed by a stop. Finally, we reach a methionine, and then there's a fairly short string of open reading frame before we hit our stop codon. And that's the longest sequence in this reading frame. Let's check the other reading frames to ensure that we don't have a longer one in a different reading frame. So scrolling on down through all 6 of these possible reading frames, it appears that the first one was the longest open reading frame. So we're going to select this because this is probably the one that our protein is in. Now we've got this in a more user-friendly format, and to get it into that FASTA sequence that we talked about a moment ago being the most useful one for analyzing genetic information in most software types, we're going to click on the start codon, the initial methionine in this open reading frame, and that's going to take us here to the FASTA sequence. And you can just highlight this and copy it and paste that directly into your Blackboard wiki under amino acid sequence.